In the previous video, we covered the topic of correlation analysis as well as feature selection. We've done some exploratory data analysis of the Boston housing data. Having an understanding of it now we can actually move into the simple linear regression modeling of the Boston housing data. That's exactly what we're going to do in this video. Just walk back a little bit. We looked at the so-called correlation analysis. One of the variables that we decided to use to model as an explanatory variable for the median housing value is the number of room on the dwelling itself. Since this actually has the highest correlation with the median housing value, I'm just going to say housing value from now on. We're going to use that to model the actual house price. Since we're doing only just a linear regression and univariate one at that, univariate basically means that we're only using one explanatory variable to explain the house price. So we're going to keep things really simple. In the future videos, we are going to go into multiple linear regression. So this is just really a simple one to start off with. Okay, here we have our let me just again just show you this just so that you actually have some perspective. We are using the number of room per dwelling. Okay, so in the data frame itself, so to select that column, we just df bracket rm, and we're just going to use the values, and we do need to reshape this in the format that scikit-learn can understand, which is in the format of matrix. Although this is just one column, we do need to reshape it to that format. Okay, store that in capital X, and for small y, which is the target variable that we are trying to model here, which is this last one here. So we're just going to dot values and store it in small y. Okay, remember the 5 steps that we mentioned in our lesson. So let me just refresh your memory on this. The 5 steps were: choose a model. Having chosen the model that you want to use, in our case linear regression, then you choose the model hyperparameters. The third step is to arrange your data into the features matrix and target vector, which we've done already. The fourth is fit the model, and the fifth and final step is to predict the label. In this case, we are not going to perform the prediction, but we will do the conduct the actual model fitting itself. So from scikit-learn, the linear model, we import linear regression, and we instantiate the model itself and fit the model of x being our room number of room per dwelling, and also the so-called median house value. So having fit that successfully, this is what it returns. Looking at the coefficient as well as the intercept, you'll notice that it's a positive slope and it's a negative intercept. Right, having done all that, let's visualize this a little bit just to see what it actually what our model looks like. So I'm just using the Seaborn, which is why the SN has here, regression plot of x and y, which is what we provided, and x label being the average number of rooms per dwelling, y label being the median value of owner-occupied home in the 100,000s. So as you can see here, as the number of room per dwelling increases, the median value of the owner-occupied home also increases. As for y, is the intercept at negative. Does that make sense? It probably doesn't make any sense, but at the same time, it doesn't make any sense to actually have any property with 0 room either. Notice that we don't really have much in the way of data that's at the lower less than 4 room. You have this is likely to be probably 3, this is probably 1 room or 2 rooms, and notice that it actually instead of following the slope happily, it actually picks up. This is one of the telltale signs to tell you in the modeling of your data, there is a specific range where your model will work. In this case, having only 2 dots here, obviously, it's not very useful in training your data. That's the first thing. Second thing here, it probably highlights the fact that as soon as you go down to 4 point something average number of rooms per dwelling, this portion here seems to indicate to you that your model doesn't work very well. There are a couple other things that really is quite striking. Notice that the price actually seems to be stuck at $500,000. There is an explanation for that. Although the dataset doesn't actually explain it, it's very likely that the price has been kept at 500,000. So that is also another telltale sign that there's some problem with this dataset that you need to bear in mind. Obviously, this will actually skew your dataset and also make your model somewhat inaccurate. What you do not know is that whether these are in the 600,000, 700,000, or even million. With that, it will definitely shift the slope of your of the slope itself. And notice that there's also an outlier here. These are things that pays to actually study to find out what is actually going on, because it's going to have an impact on the model itself. If that happens to be, let's just say, not recorded correctly, you might want to drop that, because again, this one outlier here is really quite massively different from the rest. Without projected, it should be around 450,000 or maybe close to $500,000. But in this case, it's actually around 210,000, 220,000. That's probably something to pay attention to. It could also be other factor that we didn't take into account of. So we shall leave that. So let's just do a joint plot as well and see what it looks like. Having the joint plot is very similar to that, except that it actually shows you the distribution itself. Notice that we actually have quite a high distribution of the house. Sorry. Now this is the median value. Okay, the axis has been flipped. Just be mindful of that. So the y-axis now, sorry, the x-axis now is the median value. The room number now is in the y-axis. Looking at this, what you can see, yeah, we probably should flip the other way around just for consistencies. MEDDV. Otherwise, I will get confused. You will get confused as well. I'll say, so, all right, that's better. Now that we actually have it in a much more consistent format, the room number on average around 6 to 7 rooms, and yeah, we don't really have much in the way of data here. But the median value, as we observed earlier, there's actually quite a high distribution of it that is actually concentrated at 500,000, and that's something probably to pay attention to. We already know that the Pearson is 0.7 as we did the correlation analysis before, and p-value is at the power of 10 to the power of minus 74, so it is very significant looking at that. Okay, so that's really how you perform model fitting using the scikit-learn library, Python library. And that's really the lesson here on how to make use of the scikit-learn library to perform your modeling using single variable or univariate linear regression. What I would like you to do now is to perform your own analysis. This time around, instead of using the room number, it will be really interesting to look at the L stat. This is the percentage of lower status of the population. That will be really interesting to understand, you know, because this is in the negative, they're inversely correlated. So it pays to actually study that and, you know, look at how it actually performs and see if the modeling can work well. So I'm going to give that to you as a task, and I'm going to step away, and you can pause the video, and I will perform the same exercise too, so that you can actually see my result, so that you can actually compare and contrast. So do pause the video now, and I'll see you a little bit later. Okay, welcome back. I've performed the analysis. I hope you've done likewise, so that you actually have some exercise to actually, get yourself comfortable with the scikit-learn library, and also how to actually walk through the 5-step. At the very least, work through the 4 steps. Looking at this, what do we have? LSTAT, remember, is the lowest percentage of lower status, and you have the housing value is what we actually trying to model here. So notice that as the percentage of the lower status of the population decreases, the house price goes up. As the percentage of the lower status of the population increases, the house prices goes down. There are a couple of things that's actually, if you really study this, there's a little bit of worrying sign and something that should bug you. There's actually a lot of concentration of a capping of 500,000, and it doesn't seem to be very linear as well. It seems like that as the percentage goes down, the curve seems to be parabolic. And as the lower status of the population increases in terms of percentage, it also seems to taper off. It doesn't seem to follow the straight line downward. There's no data observed down at this portion. It just seems like the price come to this point around 150,000, and it just level off at that point. And this is where you'll find that your data is telling you that linear regression is not really a good tool to model this. Nevertheless, it's a good exercise, and it pays to actually study your individual features and understand how it actually interacts with your target variable. And again, if we look at the same slightly different plot, but on the same variable, you have the again the lower proportion as well as the median price value. Again, you look at the distribution itself, and basically you can observe the same thing, but the p-value is just as high. 10 to the power minus 88 again is significant, but now that we have zoomed the actual scale out, it just looks like that there is definitely a non-linear relationship here. So I hope this lesson has been extremely useful for you. In this lesson, what we have covered really is the scikit-learn library itself, how to fit it. Of course, we cover other really important things too, is that observe, pay attention to your own data, and look for something that's give you the warning sign, such as the capping of data, lack of observation, non-linearity of your data itself, and yeah, so I hope you have found it useful, and that's pretty much the end of this video. In the next video, we're gonna go into a slightly different regression, move away from linear regression. Now we're gonna move into robust regression and see how they will improve our modeling effort. So I look forward to seeing you in the next video.